All right, so this is day 2 of composite functions. And so today what we want to do is not only compose the function, but we also want to evaluate given a certain value. So we are working with the functions f of x equals 5x minus 1 and g of x, which is 3x minus 2x squared. So first we want to compose the function. And so remember, when we do this, we're taking the entire g of x function and inputting it into the f of x function. So for every x in f of x, we are going to input 3x minus 2x squared. So if we do that, we will get f of g of x equals 5, and then in parentheses, remember those parentheses, we will get 3x minus 2x squared minus 1. Okay, so then now if we were to simplify this a little bit further, we can use the distributive property and multiply that 5 in, and we will get 15x minus 10x squared minus 1. Okay, and so now I'm just going to reorder the terms a little bit because we always want our highest degree first. So we want negative 10x squared first, and then 15x minus 1. Okay, so that is f of g of x. So now what we want to do is evaluate f of g of x at x equals 3. So now in place of every x, we are going to substitute in a 3. Okay, so if we do that, we will get negative 10 in parentheses 3 squared plus 15 times 3 minus 1. Okay, so then evaluate it a little bit further, we will get negative 10 times 9 plus 45 minus 1. So then now if I were to multiply negative 10 times 9, I would get negative 90 plus 44, and then negative 90 plus 44 gives me negative 46. So f of g of 3 is negative 46. And that is your answer. Okay, and now there are two different ways that we can do this. So I kind of want to show you both ways. So first, let's compose the function g of f of x. And so if we do that, g of f of x, this is going to equal, this is going to equal 3 times 5x minus 1 minus 2 times 5x minus 1 squared. So before we start using distributive property or anything like that, what we want to do is we want to evaluate that 5x minus 1 squared. So we can use the distributive property to multiply in that 3, but we don't want to distribute in that negative 2 yet. So if we use distributive property for 3 times 5x minus 1, we will get 15x minus 3. And I just expanded out 5x minus 1 squared. And it's still being multiplied by negative 2, so don't forget that as well. And then if we were to use distributive property again, we would do 5x times 5x plus 5x times negative 1 plus negative 1 times 5x plus negative 1 times negative 1. So just distributive property there. And we would simplify down to get 15x minus 3 minus 2 times 25x squared minus 10x plus 1. And then now we need to distribute in that negative 2. So when we do that, we will get 15x minus 3 minus 50x squared plus 20x minus 2. So now what we want to do is kind of rearrange our terms and simplify as much as we can. So when we do that, we will get 50x squared plus 35x minus 5. I'm going to make this more of a 2 here. And then, so now here's where things can look a little bit different. When you are evaluating, there are two different ways that you can do this. You can do this like we did before in the first problem, but you can also take the inside function and evaluate at 3. So at x equals 3 for the inside function. So we're going to take f of 3 and evaluate there. So we're going to plug that in to the f of x function. So we will get 5 times 3 minus 1. And then if we were to simplify, we would get 15 minus 1, which is 14. Okay? So now we've just evaluated f of 3. So now what we want to do, since we have g of f of 3, we want to input our result from f of 3 into our g of x function. So what we want to do is find g of 14, because that is the output of f of 3. So we want to put that in as our input into g of x. So now we want g of 14. So if we were to input 14 in instead of x into the g of x function, we would get 3 times 14 minus 2 times 14 squared. And then if we were to simplify this a little bit further, we would get g of 14 equals, here, let me change my pen color here. G of 14 equals 42 minus 2 times 14 squared, which is 196. Okay, now if we were to simplify this a little bit further, we would get g of 14 is equal to negative 350. Okay, so now are these the same thing? I just want to double check and make sure that the method that we used first is the same thing as using this method. So in yellow, I'm going to do the next function, or the next method, just like we did before. So now we're using that function that we composed in our box to the left. So we have negative 50x squared plus 35x minus 5. And so now I'm just going to input in a 3. So directly inputting in 3 into that function, we will get negative 50 times 3 squared plus 35 times 3 minus 5. And then if we were to simplify this a little bit further, let's do 3 squared first. And we'd get negative 50 times 9 plus 105 minus 5. Okay, and then simplified a little bit further, we would get g of f of 3 is equal to negative 450 plus 100, which is equal to negative 350. And so now you can see that this is actually the same answer. We've just used 2 different methods here. And so whichever method works best for you is fine. You can use the method that I wrote in blue and green, or you could use the method that I wrote in yellow. You're going to get the same answer regardless. But if you used the second method that I talked about, you might not always have to compose the functions in order to find your answer when you evaluate. So if it's just asking you to evaluate your function, one method might be quicker than the other. So keep that in mind. You can use either one though, whatever is most comfortable for you and whatever makes the most sense to you, go ahead and use it because you're going to get the same answer anyway. So now for your homework tonight, these 4 problems are on your homework, and then I just want you to continue on. There are a couple more problems on your homework, but we've already talked about the first 4.